Hey guys, I'm gonna do a little demonstration video how to repair STL files when you are getting ready to print. If you just watched my last video, you can notice that I had a part that I'm printing for a friend, and I printed it. It took six and a half hours and like 40 meters of material, so it was quite a long print. And only I missed it. I should have picked up on it or whatnot, but I didn't. And so it's kind of learning with this program as well. So just to give you an idea, you can fix parts, and it's recommended that you just run it through the Netfab software. Well, they do have a free software version, but they also have a cloud version on the internet, Netfab. If you just Google Netfab Cloud, it will uh, it will come up. Um, so just to give you an idea, if you've seen my last video, so I'll just get right into putting the part in. And let me see here. Let's just go to Cura, sorry, Simplified 3D. I'm just going to import a part. Now these are the two that I already have fixed, but I'm just going to put in. Now it's pretty small. It comes up very small here. Okay, so for some reason, even though it's scaled at 25.4, because this part was scaled in inches and it converts it to millimeters. So, but 50, that should scale it. We're testing it right now, so the broken part, he's going to pick it up today, and just to have a put it sideways on the build. So I'm just going to generate support material, just to do this quickly. Okay. And I'm just going to add a process here. It's going to be pretty straightforward. I've got all this set up, so okay. And I'm just going to prepare to print, and we'll see here now what I'm talking about. For one, it says 3 hours and 15 minutes. That print time is way off because it was crazy. I was just, oh yeah, 3 hours is not too bad actually, and when I went out and checked it 3 hours, it was like 40, 44, 45% or whatnot, and I was like, man. So I was expecting it to be a little bit longer than it actually took. So the one good thing about this program, um, you can manually scroll through, and it shows you everything. You can press play and pause, like I was saying. I did a video the other day. So as we come up, and right over here where this joins, we're going to get in and zoom in here. You can see the two parts, okay, and the supports are coming up. And you look how it mates to this. It's not actually joined. Oops. You can see that. So I had the part printed and I was all excited. I was like, oh sweet, because I tried to print it before, and I had an issue with the support material, and this was on a different slicer. So I kind of put it on the back burner because, as you can see, there's a huge gap. If I can get this scaled in here. It's pretty much hollow. I'm going to get this right here because it's a little bit, you can get the idea. So it's actually two parts and it's not fused together. So I was taking the support material off. It pretty much broke away. So it was a failed part. So Kind of sucks when you print and you use all that material, and that happens. So I'm going to show you the difference. Oops, I gotta get out of here. I'll show you what you do with that file online. You come here. I'm just going to upload another because I just fixed these two files. But come here and I'm going to pick the left leg and there's the right leg because they're mirrored. It's for the part is actually for a Sky Hero quadcopter. So he designed them and whatnot. So he wanted some custom parts printed. So it just uploads, repairs it for you. Then you just save it. Just save it anywhere. But we'll go back in. And I'm going to import. And this is the fixed part. Okay, still comes up small because it was, like I was saying, it was made in inches. So I'm going to flip that 120 degrees. And we're going to generate our supports based on overhang angle. And you can change that. I can add more if you like. You just have to come in and you can, if you wanted to, you can just put a few more here. Like that. Flip it upside down. You can just add a couple more here if you like, if you feel that. There. And I'm going to actually remove some because don't need them in these holes. Just move a couple there, it's fine. And you can also do this and enable cross section. And you can see the material and how they are in the circle if you want to really get in. So we won't get in too much into that. We'll just close that out. Like that. Alright, so just got to add a process. I know that everything is the same. I'm going to prepare to print and let it slice. Now we'll see the difference here. Let's just show you in preview mode. Okay. So we got our part coming up, and now you actually see it as one part. You can see it doing its outline here, and I never picked up on that last night. So it's kind of not a trial and error, but I just I just missed on it. So right now this part is fused, and you can see, so that should be one solid part. So he's going to come up and he's going to pop by and pick up that part that it was failed last night, just to check and make sure that the scaling for like the holes and whatnot line up. But I knew the total length, so how I got to 1550 on the scale was just keep bumping it up until the length of it was his dimensions, plus or minus. I think it's going to be 2 millimeters or 1 millimeter too big, but I like to have just a little you need for tolerances and stuff. So hopefully that works out, the broken piece or whatnot, and we'll just go ahead and print these two left and right fixed parts. So that is basically a little rundown on how to fix an STL. So if you ever doing any parts that are generated or somebody has made, and you want to make sure, just run the part through Netfab, and that should fix up any holes or errors or anything like that. So anyways, as always, thanks for watching.